My research field is the macromechanics of materials, that is, the study of how phenomena at different length scales affect the behavior of materials when subjected to loads. Since granular materials have a clearly defined microscale at the level of individual grains, much of my research is focused on studying granular materials and especially phenomena which are very characteristic of granular materials, such as localization of deformation, granular flow, or grain crushing. I use three different approaches. One is constitutive modeling, that is, the use of mathematical theoretical descriptions of material behavior. The second approach is numerical simulation, that is, the use of computers and software codes to simulate the behavior of granular materials. And the third approach is the use of experimental testing to actually test the material behavior in real life. Within the granular group, I have had the opportunity to enrich my scientific approach, which originally focused mainly on the continuum description of granular materials, both theoretically and numerically. And now the approach consists also to a large extent of a discrete modeling, that is, modeling and describing the behavior of granular materials at the level of individual grains. My research has attracted funding from both UK and EU sources. Part of this funding has been individual, such as, for example, a Marie Curie Career Integration Grant. But of course, being part of the granular group and indeed of the University of Edinburgh has allowed me to also participate in a much larger collaborative research projects, and this has been a huge benefit to both my extending my career collaborations and also to my overall research work.